So you're driving along, you glance down at your speedometer, and it says 60 miles per hour. Pretty straightforward, right? It's just one number telling you how fast you're going. But what if I told you that number is only giving you like half the story? Today, we're going to break down the huge difference between speed and velocity, and trust me, it matters a lot more than you probably think. And hey, speaking of that number on your dash, did you know it might not even be totally honest with you? Yeah, people in the industry have admitted that speedometers are often set a little optimistically. Basically, they show you're going slightly faster than you actually are, partly to help you avoid getting a speeding ticket. It's a tiny detail, but it really highlights the fact that your car isn't telling you everything about your motion.
Because look, even if that speedometer was perfectly accurate, it's still missing a massive piece of the puzzle. It tells you how fast, but it tells you absolutely nothing about where you're going. And that little piece of missing information, your direction, well, that's the secret ingredient that turns simple speed into the much more powerful idea of velocity.
All right, to really see how this works, let's ride along with the driver on a totally normal trip across town. This everyday example is going to help us unpack all these big ideas: distance, displacement, speed, and velocity in a way that just clicks. So picture this. Our driver is heading out to try a grand new restaurant on the other side of the city. She hops in the car, turns the key, and starts making her way through all the twists and turns of traffic, heading for dinner. Okay, let's get the facts down. She leaves at 6 p.m. sharp, gets there at 6:50, which means the whole trip took 50 minutes. When she checks her odometer, it shows she drove 30 miles. But, and this is the really interesting part, if you were a bird and could fly in a perfectly straight line from her house to the restaurant, it's only 6 miles away to the northwest. These two numbers, 30 miles and 6 miles, are the key to understanding everything. Now, to figure out why we have these two totally different mileage numbers, we need to grab two tools from our physics toolkit: scalars and vectors. These are the basic building blocks we use to describe any kind of movement, really. First up, let's talk about scalars. A scalar is super simple. It's just a number that tells you how much of something there is. It's just the magnitude or the size. Think about things like your age or the temperature or how much your coffee costs. They're all scalars. They're just numbers, no direction needed. And then we have vectors. Now, vectors are a bit more sophisticated because they have both a magnitude and a direction. They don't just answer how much, they also answer which way. And adding that direction in there, that's what makes vectors so incredibly useful. So let's connect this back to our driver. That 30-mile number on her odometer, that's a scalar. It's the total distance she covered. But that 6-mile straight-shot path to the northwest, that's a vector. In physics, we call that her displacement. And right there, that's the core difference that separates speed from velocity. Okay, let's actually visualize this. We're going to apply these ideas to our driver's trip and see how one single journey can be described in two completely different ways. You see that long, winding road she took, all the lefts and rights and stoplights? That path represents the distance she traveled. That's our scalar. But that straight arrow pointing directly from her starting point to the restaurant, that's her displacement, the vector. It's just the net change in her position, and it completely ignores the scenic route she had to take. So, to boil it all down, her distance was 30 miles. That's a scalar. Her displacement was 6 miles to the northwest. That's a vector. Two totally different measurements describing the exact same trip. Now that we've got the concept straight, it's time to do a little math. This is where the rubber really meets the road. We're going to calculate her average speed and her average velocity, and I think the results are going to surprise you. So let's start with speed. Remember, speed is our scalar, so to calculate it, we have to use the total distance she traveled. Speed doesn't care about direction at all, just that full winding 30 miles of road she covered. So knowing she drove 30 miles and it took her 50 minutes, what do you think her average speed was? To figure this out, it's pretty simple. We just divide the total distance she drove by the time it took. So that's 30 miles, which is about 48,280 meters, divided by her 50-minute trip time, which is exactly 3,000 seconds. And we get 16.1 meters per second. Now, to put that in more familiar terms, that's about 36 miles per hour. That number represents her overall pace along that entire 30-mile journey. Okay, but now let's switch gears and talk about velocity. Remember, velocity is a vector, which means it is all about direction. So we're not going to use the 30-mile distance. Nope. To calculate velocity, we have to use her displacement, that 6 miles straight line path. So for that very same 50-minute trip, what was her average velocity? Would you look at that? Her average velocity was only 3.2 meters per second northwest. Not only is that number 5 times smaller than her speed, but we absolutely have to include the direction, northwest. Because velocity isn't just how fast you're going, it's the rate at which your position is changing in a very specific direction.
So what, right? We have two crazy different numbers for the same trip. Is this just some weird physics trivia? No way. This distinction between speed and velocity is actually mission critical for so many technologies we use every single day. Think about your phone's GPS. It's constantly calculating your velocity, not just your speed, to figure out the best route and give you that accurate arrival time. A pilot flying from New York to London can't just know the plane's speed. They need its velocity to deal with crosswinds and the Earth's rotation. And in the world of physics, all the big ideas like acceleration, force, and momentum, they're all defined by changes in velocity, not speed.
And this leads us to a really cool kind of mind-bending idea. Because velocity includes direction, you can actually be accelerating even if your speed never changes. When you go around a curve in your car, even if your speedometer is locked at 30 miles per hour, your direction is changing, right? That means your velocity is changing. And any change in velocity, any change at all, is technically acceleration. So let me leave you with this final thought to chew on. A race car flies around a track and crosses the finish line at the exact same speed it started the lap with. Its position is the same, its speed is the same. The question is, has it accelerated? Well, if you truly understand the difference between speed and velocity, you already know the answer.